There are many situations in our everyday life where we encounter number sequences. For example, say 200 rands are deposited in a bank at a 5% rate of simple interest. The account balance at the end of each year is given as shown. In another example, a man goes for a walk for 15 minutes every morning and increases this time by 5 minutes every week. After 4 months, his walk lasts for 1 hour. The time spent on the morning walk, week by week, can be represented as the sequence of numbers shown. Finally, look carefully at the arrangement of balls shown. Now look at the pattern of the sequence of numbers in each situation. In each situation, you can see that each term after the first term is obtained by adding a constant to the preceding term. Do you remember that such sequences are known as arithmetic sequences or arithmetic progressions? Let's explore arithmetic progression a bit further. In the arithmetic sequences we've looked at, we have observed that each term exceeds the previous term by a fixed number. Remember that in an arithmetic progression, this fixed constant is known as the common difference. The common difference in an AP can be any real number, and hence it can be negative, positive, or 0. These will give decreasing, increasing, or constant arithmetic sequences respectively. An arithmetic sequence can be described by using its first term and the common difference as shown. In general, if the first term is A and the common difference is D, we can write all the terms of the arithmetic sequence as shown. Note that an arithmetic sequence advances in a definite pattern. For this reason, the arithmetic sequence is called arithmetic progression or AP. Now let's explore the graphical representation of an arithmetic progression when it is plotted against the number of terms in an XY plane. Consider an arithmetic progression with a common difference equal to 2 and a number of terms n equal to 6 as shown. Label the number of terms on the x-axis and the corresponding terms on the y-axis. Now, plot a term against its corresponding order number as shown. Observe that for positive common difference D, we get a straight line heading upwards. Now plot an arithmetic progression with a common difference equal to -4 and the number of terms as 5 as shown. Note that for negative common difference D, we get a straight line heading downwards. Now observe that for the common difference D equal to 0, we get a line parallel to the x-axis as shown. In such a case, AP represents a straight line. This is also called linear progression. Hence, our discussion and observation can be summed up as shown. Let's consider an arithmetic progression A1, A2, A3 and so on till AN. Suppose the first term A1 of AP to be A and let the common difference of an AP be D. We know that in an arithmetic progression each term except the first term is obtained by adding the common difference to the previous term. Therefore, by definition of AP, we have A1 equal to A. Similarly, by definition, the second term a2 is obtained by adding the common difference d to the previous term, that is, the first term a1. As a result, the second term is a plus d. Likewise, the third term, the fourth term and so on can be obtained as shown. Observe closely the number of the term and the coefficient of d. Note that the coefficient of d is equal to 1 less than the number of the term. For example, for the first term a1, the coefficient of d is 0. In the second term a2, the coefficient of d is 1. In the third term a3, the coefficient of d is 2 and so on. Thus, the nth term of an arithmetic progression is equal to a plus n minus 1 times d. In fact, the nth term of AP is known as the general term of an arithmetic progression. Let's generate an AP if its general term is 3n plus 6. We know that the nth term of an AP is its general term. Therefore, we get equation 1 as shown. Now, substitute 1, 2, 3, 4 and so on for n. As a result, we generate an AP with the first term 9 and the common difference 3 as shown. Now find the number of terms in the given arithmetic progression. In the given AP, the first term a equals 3 and the common difference d equals 3. Let there be n terms in the given AP. Then the nth term is given by the general term as shown. Label this equation 1. In the given AP, the nth term is 111. Hence, substitute an equals 111, a equals 3 and d equals 3 in equation 1 and simplify to get n equals 37. What is the 20th term of an AP if the fourth term is 8 and the common difference is minus 2? We know the formula as shown in equation 1. Now substitute 20 for n, 4 for m and minus 2 for d in equation 1. Substitute 8 for the fourth term and then simplify to get the 20th term equal to minus 24. Let's go over some properties of arithmetic progression.